Welcome to Talkin Science, where we dive into the latest news from space and science. Tidbinbilla's Richard Stephenson has beamed in. I'm very excited for this chat. Richard, thanks for your time.
Thank you, Matt.
Well, before we get into it, a quick reminder that you can get behind-the-scenes goss and early access to all Trekzone podcasts by becoming a member today. Click the join button on any Trekzone video. Go to the Trekzone/support or put your phone up to the QR code on screen throughout the show. Richard, we know that Tidbinbilla is a critical link for NASA's Deep Space Communication Network, providing one of 3 up and downlink facilities for spacecraft. But can you tell us about your specific role?
I'm part of the operations team in Canberra. I'm one of the operations team leaders. And essentially we have a crew of 16. And for daylight hours, currently that's 8 till 5, we'll control not only the Canberra assets, but also the assets in Madrid and Goldstone, the other 2 NASA DSN sites.
With so many missions currently out in the solar system and beyond, do you have a favourite spacecraft to talk to?
You have the nostalgic spacecraft and you have the exciting spacecraft. It's like going into a pub and picking out a particular person you want to talk to. If you look at the Voyagers, obviously we talk to Voyager 1, only Canberra can talk to Voyager 2 now, 22 billion kilometres away. That I've been in Canberra operations now for 32 years. And when I started, so Voyager 2 was just going through its Neptune encounter and now in interstellar space. So it's a spacecraft that's I've spent my entire career tracking and hopefully probably until I retire. But then you have the other spacecraft like Parker Solar Probe, and which is a far more dynamic mission, I suppose. So getting so close to the sun and then so zooming out to almost the point of the orbit of Venus before flying back in again. So Voyager 2 will probably always be my favorite, but there's always something new, so the tracking of MSL so to Mars was incredible. So all the rovers around Mars are incredible, and we do those as well. And I should point out that it's not only the NASA spacecraft that we support, but it's also other agencies' spacecraft as well. We are tracking a lot of ESA spacecraft. CSIRO does manage the ESA site in New Norcia as well, and they have a single antenna. And we have a 70-meter and 3-beam waveguides, and we complement each other. So we are supporting a lot of ESA spacecraft because their network has almost hit saturation point, I think, especially with the Mars missions. But we also do the JAXAs, Arab Emirates is a new one, the Indian Space Agency as well. So, up till probably 6 months ago, we had mid-30s supports, but with Artemis being launched in November, hopefully, carrying 13 CubeSats, that's made life a little bit more interesting for us because now we're suddenly having these huge influx of the smaller spacecraft, which we still have to treat as the same as any flagship.
Well, how does the relay back to each mission's control work? Is it real-time with each DSN station as a conduit, or is it more like a buffer where you receive the set of instructions and pass it on?
It differs from mission to mission. It depends. Some missions might need that real-time feedback. We have the Chandra, so telescope, which is obviously a real-time support. They'll send commands. They need to see those acknowledged in their telemetry to send other commands. So that's a real-time support. But we also have supports like Geotel, for instance, where it's a regular support that comes up, and we'll track it, we'll record the data, and then when project comes in the following morning, they can grab it on their PC. The whole network works like a spoken hub, so all the data coming down from Canberra, Madrid, or Goldstone goes through the JPL hub. So if you are a project, you would actually subscribe to data from JPL. and they deliver it to you.
What about weather? How does that play a part in communications? You're obviously receiving and transmitting on long wavelengths, so I'm guessing the light weather, not so much, but what about when it gets really heavy down there in Canberra?
Well, we actually sort of track on 3 discrete bands for the spacecraft. Sierra band is 2.2 sort of gig, and it's big and robust. It's, I should say, fairly long wavelength in relatively. So we're not really concerned about weather there. X-ray band, we have to be careful with the rain. Light rain is okay. Heavy rain can wipe out a signal. And then it all comes down to margins. If a spacecraft has a big booming signal, obviously it can ride the rain or surf the rain. But if you're looking at spacecraft that are right on the hairy edge, for instance, the Voyagers, then that can be the difference between receiving good data or a total washout. We also have, and that's the 8 gig, when you go up into the 26 or 32, which is our K-bands, that can be, we can actually see degradation with heavy cloud going over. And certainly, so anything more than a very small sprinkle of rain can wash it out completely.
Now, we've had a few missions land on Mars this year, plus Hayabusa 2 returning from asteroid Bennu in December. OSIRIS-REx leaving its asteroid home 2 a few weeks ago. Is it more exciting to hear from the spacecraft or rover at those milestone points, or getting the reaction from the humans waiting anxiously for the news?
For us, it depends on, I said, the milestones of the mission. So with Hayabusa, it was one after the other. I mean, so they really did sort of nail that poor little asteroid with everything from little tags flying down to ballistics to finally scooping up and returning. With OSIRIS-REx, so it wasn't quite so ambitious, but they've got their sample now and returning as well. So you've got these projects with lots of little milestones. And obviously, if you look at New Horizons and the Pluto mission, that milestone took 9 years. So you're not holding your breath for that. With the Mars missions, obviously the landings are the most exciting, but then you have the little key milestones with, for instance, the new helicopter as well, which was incredible. All of which comes through our relay spacecraft around Mars. We do have Mars Odyssey and Mars Reconnaissance Orbiter that act as a primary relays, but we can also use the ESA spacecraft as well, MEX and TGO, Trace Gas Orbiter, to also relay that UHF signal to Earth through the Electra system that we have around Mars.
NASA's Artemis program is gearing up for lunar missions in the next few years. I'm assuming Tidbinbilla will once again be providing critical support. Like the Apollo missions, what's the buzz like around the place?
There is a buzz, but we're not sure why. We haven't really had a huge amount of clarification. The DSN SCAN, which is essentially the NASA agency that's responsible for all spacecraft communications, has 3 networks. They have the near Earth. They have the TDRS network, which covers spacecraft fairly close to Earth, and then our deep space network. When you're looking at what's required for Artemis and Lunar, so it's a cross between close Earth and deep space. The optimal antenna size is around about 18 meters, and we have 34 meters. So the DSN may support a little bit differently to our normal spacecraft. But yeah, look, it's going to be an exciting mission. We will be supporting it. We were told that a few years ago. We are now human spaceflight certified, so we can pass data from human spaceflight back to JPL as well. So we're just hoping that obviously the November launch won't be crewed, but hopefully the next ones will. And when I first started in Canberra operations, so 30 odd years ago, we were still doing shuttle. And before the TDRS network kicked in, and so meant that they were talking directly to White Sands, we did actually communicate with astronauts, and it'd be interesting to see. So whether I get to speak to another astronaut before I retire.
Obviously, there is a difference between talking to robotic missions and talking to humans. Having that feedback as well from astronauts. So you say you work with the shuttle. What's that like to have that two-way communication with a mission?
Brief. with the shuttle, it was very brief. Essentially, with it being such low Earth orbit, so they are more or less from horizon to horizon within 5 or 6 minutes. So you had just enough time to say good day and thank you very much before they disappeared over the horizon. And they actually used to disappear over the Pacific, and they were entering their zone of exclusion at that point, which is why the TDRS network came out and took that away. So it was like an umbrella system sitting above shuttle, and each one relayed down to White Sands. So they had continuous coverage as they orbited. But no, it'll be different. And I said, so we know we're doing Artemis, but we're not sure whether it's a 24/7 coverage, in which case we have to start allocating assets. We're not sure whether, obviously from Artemis 1 or EM1 to the time there is a crew on the next one. There may be an opportunity to build a smaller antenna at each site that could possibly be committed to the lunar missions 24/7.
Richard, very exciting times ahead indeed. Looking forward to hearing more about our role and our supporting role of these missions. As you say, not just NASA, but ESA missions as well, and other space agencies coming online as well. So many missions happening in the solar system. Thanks for a little bit of your time this morning as part of Talkin Science Fest, and hope we can chat again real soon.
Pleasure. Catch you later, mate.
Keep up to date with Twitter. Catch new podcasts daily on YouTube. Plus, we're beaming to your favorite podcast app 5 days a week. Just search for Trekzone and subscribe.